Alright, we're ready for section 7.2 on valence electrons. Here's the objectives. 1, be able to define valence electrons, know what they are, and be able to indicate how many every atom has, and then be able to draw Lewis structures or Lewis dot diagrams for these atoms. First of all, when we're talking about valence electrons, what we mean are electrons that are in the outermost shell, that top floor of the hotel, if we're thinking of that way, the outermost level, upper. So let's take a look at gallium, which if we write it in the shortcut method, it looks like this. And one of the reasons why we rearrange these, and this particular book didn't do that, is because by doing that, you can easily see what is in the outer level. So rearrange, this would be like 3D10, finish off 3D10, 4s2, 4p1. Outer level is going to be the ones that have the highest principal energy level, so 4s here in this example. So these right there are my valence electrons. So we know there's 2 of them in the S, 1 in the P, so we have a total of 3 valence electrons for gallium here. Okay, electrons in the outermost principal energy level of an atom are, I think I lost here. Anyway, the electrons in the outermost principal energy level are the valence electrons, is what I should have said there. The outermost energy level is sometimes called the valence shell. So we're talking about the valence electrons. They would be in the valence shell. So sometimes the outermost level is called the valence shell. And the ones electrons that aren't out there, those are simply called the core electrons. So you have the valence electrons on the outside. Core electrons would be the ones on the inside. Alright, so let's take a look at some of these examples. So here's magnesium. Here's its electron configuration. And you can see that the outermost principal level, if we look at all these numbers, the biggest one is 3. So we're talking about those electrons right there. So the valence electrons for magnesium are 2. There's 2 valence electrons on that one. If we look at sulfur, now we're looking at, there's 2 things with 3 principal energy level. Those right there, 3s2, 3p4, that totals 6. So there's 6 valence electrons. For gallium, this one is a little more complicated. Once again, this is why, this book doesn't rearrange, but every other time I've ever seen it, they do, and we will do that. We will always rearrange ours, and then it becomes a lot simpler. But if we look at, okay, here's a 4 level right there, here's a 4, so we would have rearranged it and said, hey, it's 3D10 and 4s2, 4p1. There's my valence electrons. Once again, there's 3. We've done that. That's gallium. All right. Sometimes, we don't want to write all that stuff out. So there's an easier way to do it, and we use what's known as Lewis dot diagrams to represent those. There's just dots written around a letter. So if we're talking about sodium, once again, we look at our outer level. There's 1. Okay, so there's 3s1, so therefore there's 1 valence electron. The core electrons are all those other ones. Those are my core. And there's my valence electron, 3s1. And the way that I'm going to do this, I'll just rewrite it over here, is you simply write the symbol, and to indicate valence electrons, we put a dot. So there we go. So this is represented by my dot right there. Let's say we want to do magnesium. Well, it's got 12 electrons. If we want to draw out the other stuff, 1s2, 2s2, 2p6, 3s2, that's 12. All right, what's my outer level? That is this. So this is my core. This is my outer, my valence electrons. So there's 2. So we'll write Mg, 2 electrons, 1, 2. There's our Lewis dot structure. So all we're doing is putting dots in for the number of electrons. Really simple, just an easier way to do some of this. Chlorine, 1s2, 2s2, 2p6, 3s2, 3p5. Okay, outer level, right there. So here's chlorine. Now usually this is how they're going to do this, alright? First two, that's my S, right? And then there's 5, and we're always going to go on each side of the atom represents a sublevel. So that's a P sublevel, there's another P sublevel, and there's the other one. Okay, so there's my 7. Don't write it like this. 1, that's a lot harder to count, harder to look at and count how many there are, than it is when they're written this way. So I always go to the right, to the left, top and bottom. You know, I don't really care where you start, but I always just do them right, left, top, bottom. All right, oxygen, 1s2, 2s2, 2p4. So you can see my outer level of those guys right there. So oxygen, and there's 6. 1, 2, 3, 4, 5. Now don't double that one up because, you know, Pauli exclusion principle says we don't double up until everything else is full. And we use every side of this atom to represent, you know, a sublevel. So separate them out and then double them up after you've got them all in there individually. All right, on sulfur, here's our configuration and our outer level, 3s2, 3p4. So we would get valence electrons are 6. They would look like this right here. 2, 2, 1, 1. Once again, don't write them like this. We don't want to do that. Potassium. There's our potassium. Notice the outer level, 4s1. 1 valence electron. It's the only 4. So we got 1 dot. Pretty easy. And chlorine right here. Oh, I'm sorry, carbon. Carbon, 1s2, 2s2, 2p2. Valence electrons are those last 4. And we would write them like that. 4 valence electrons. Okay, here is the assignment, and I do want you to do this. This is something that I am going to have you hand in. I am going to give you a grade on this paper. You need to do it on paper, so please write it on a piece of paper to hand in on a notebook paper. Answer these questions. They won't take you very long. Doing Lewis dot structures doesn't take long to do. So just look for the outermost levels and write the dots around the symbol. And then answer these other questions. None of these things should take you very long at all, but we are going to hand this in for a grade. So make sure that you do this. Have it ready. We'll hand it in at the beginning of class. So, the end. There we go.